Hello, my name is Pawlak from the Jagiellonian University in Krakow, and I would like to tell a few words about the connection between the long secondary period phenomenon and the red giant evolution. By red giants here I mean both RGB and AGB stars. So for the purpose of this study I used the Ogle collection of the long period variables in the Large Magellanic Cloud, and especially the sample of Ozark variables, both the ones that show LSP and those that don't. And I compared their location on both period luminosity and CMD diagrams. So here we have the comparison of these two samples, the LSP and non-LSP stars in the period luminosity plane, the period luminosity relations formed by LPVs are marked with the solid lines, and we can see that the picture is quite different for the LSP and non-LSP stars. The global maximum is in a different place, and what's more, for the LSP stars we see at least two local maxima, one at around B3 and another around B2 sequence. If the relative density distribution of the LSP stars, so the fraction of the LSP stars compared to all the long period variables, we see another local maximums or another local overdensity regions between the sequence C prime and C, so the sequences corresponding to the first overtone and the fundamental mode. So this shows us that there might be more than one place where LSP occurs on the course of the giant evolution when the star is moving from the short period range to the long periods and crossing the different sequences. It might be that LSP appears and disappears more than once. Similar analysis was done for the CMD plane, color magnitude diagram. And here again we have the non-LSP stars at the top, the LSP stars at the bottom. And the first impression is that the image is quite similar for both LSP and non-LSP stars. So that the general point is that LSP can appear more or less everywhere where the LPV stars appear. The bulk of LSPs appear right below the TRGB, the tip of the red giant branch, which kind of shows us that there is a significant contribution of the RGB stars in the LSP population, but obviously there are also LSP stars above TRGB, which means that the population of LSP stars is a mixture of RGB and AGB stars. Here we again see the relative distribution, the relative density of the LSP stars, so the fraction of the LSP stars in different regions of the CMD diagram. And this reveals an interesting feature, because we again see more than one local maximum. So one local maximum is right below the TRGB, and another, this time global maximum, is on the AGB, which again can be a hint that LSP may not be a single time phenomenon but a recurring phenomenon that may appear more than once over the course of the red giant evolution. Final interesting feature is the fact that the global maximum of the LSP relative density seems to overlap with the region where transition from oxygen-rich to carbon-rich state is happening. So here the carbon-rich stars are marked in red, and they clearly appear in the same area where the global maximum of the LSP density appears. So this is a hint that there might be some connection between LSP and the transition from oxygen-rich to carbon-rich. So this was just a quick summary of the results. If you are interested in the details, I kindly invite you to see my recent paper. The references are on the screen. And with this, I would like to thank you for your attention.